A pipe bursts in a dark residential basement, flooding the floor in seconds. The homeowner needs a plumber immediately. For emergency-driven service marketplaces, passive in-app messaging guarantees failure. A plumber elbows deep in a repair is not actively refreshing an app to check for new messages. The solution to this latency is active push infrastructure, a real-time SMS lead notification routed directly to the provider's device. If a local service directory relies on users happening to open the application at the exact right time, it generates no reliable revenue. Missed leads quickly turn a marketplace into a dead product. Transitioning from passive in-app messaging to an active push infrastructure dictates whether a platform loses a user to a competitor or closes a profitable job. We are going to deconstruct the exact data pipeline of a single real-time lead within the ServeSpring application. This UML sequence diagram maps our analytical method. We will trace a completed SMS notification backward from its final delivery point, mapping its path in reverse through the telecom node, server function, and database, all the way back to its origin at the user interface. Along this path, we will examine three distinct architectural pillars: serverless backend integrations, secure database segregation, and UI state gating. A failure or misconfiguration in any single one of these pillars severs the connection, breaking the entire chain of data liquidity. Tracing this lifecycle in reverse reveals exactly why a robust backend architecture is the mandatory prerequisite for any seemingly simple front-end feature. We begin at the end of the sequence, the precise moment the local professional receives a text message alert on their device. The infrastructure responsible for this final delivery is a Twilio API integration, triggered remotely by a backend serverless function. Looking at the expanded Twilio node, we see the exact SMS payload, the customer's name, phone number, contact time, and job category. But before reaching a phone, it hits a compliance barrier. Twilio requires A2P 10DLC registration, a strict verification gate for application-to-person messaging. Even for initial testing purposes, navigating the telecom console requires explicitly configuring geo permissions and SMS pumping protection. Without these safeguards, the platform is exposed to massive financial risk from automated fraud billing. This entire sequence is event-driven. The serverless function doesn't run on a schedule. It fires automatically the millisecond a new record is inserted into the database. Executing this final mile of lead delivery requires navigating stringent external compliance and telecom security protocols, rather than simply writing standard API calls. Constructing this serverless pipeline required resolving a specific infrastructure error that crashed the backend execution entirely. The development logs revealed a PMAP not defined error occurring precisely within the server function transformer. The root cause was an inline mapping construction colliding with the transformer's strict variable scoping rules. To fix this, we replaced the inline tuple with a standard for loop, instantly resolving the scope and allowing clean execution. Relying on auto-generated code for rapid development requires human engineering oversight to catch and resolve abstract variable scoping errors inside asynchronous server-side logic. Moving one step further backward in the sequence, we reach the database layer, where the lead event actually originates. Before a database trigger can fire, a customer must first be able to locate the professional on a live, interactive map. This creates an immediate security conflict. The primary database table holds the public coordinates required for the map, but it also stores highly sensitive information, including Stripe IDs and owner identification documents. This master database table contains both public coordinates and sensitive identity columns side by side. Sending everything to the client is a security risk. The solution is a restricted database view. We expose only the required listing fields, keeping sensitive information permanently masked. When a customer taps that secure public listing and fills out a contact request, the application inserts a single new row into an entirely isolated lead requests collection, which in turn fires the server function. Building functional, public-facing marketplace features demands strict data segregation directly at the database view level to prevent catastrophic privacy breaches. We trace the pipeline back to its absolute origin point, the professional's initial onboarding dashboard. Here, we encounter a critical systemic dependency. If a service provider has not inputted a valid US phone number, the entire downstream SMS infrastructure we just reviewed will silently fail. To prevent this failure, the front-end state mechanism is designed to strictly gate the provider's ability to activate their public profile using a Can Go Online toggle. This logic tree maps the evaluation criteria. The pathway to the Go Online state is securely blocked until the Has Contact Info flag evaluates to true. The system requires exactly 10 digits for the phone number and a non-empty city location before it unlocks. For existing incomplete accounts, the UI enforces aggressive fallback behaviors. The platform deep links users directly to specific form steps and deploys forced validation banners to ensure absolute compliance. Rigorous, uncompromising front-end state gating serves as the foundational checkpoint that protects the integrity of the entire back-end data pipeline. Now we can zoom out to view the fully assembled end-to-end marketplace architecture. Tracing the sequence forward, UI state validation unlocks the provider's profile. A customer submits a request, routing data into the lead_requests table, triggering the serverless function. The function formats the payload, passes the Twilio compliance check, and reaches its final destination. The compliant API delivers the instantaneous real-time notification to the provider's device, completing the circuit. A successful marketplace transaction is never a single action. It is a precisely synchronized alignment of strict data constraints, secure routing, and responsive event listeners. Modern development relies heavily on AI-assisted platforms like Lovable to accelerate these builds. But viewing these tools as autonomous developers that can automatically generate fully functional, secure applications without structural guidance is a severe miscalculation. Deploying this feature required precise manual interventions. We had to fix transformer variable scoping, build isolated database views, and enforce strict front-end validation loops to ensure the system functions safely. AI drastically accelerates the generation of boiler code, but it lacks an intuitive understanding of complex business logic, telecom compliance, and edge case security risks. In an era of automated code generation, anticipating system failures and enforcing strict architectural boundaries remains the irreplaceable role of the human software engineer.